Welcome to the lecture series on object oriented analysis and design. This is the second lecture. We began with the understanding that a typical user interacting with the machine would work based on the task at hand. The case study was the vending machine. A vending machine that allows users to buy snack items. That is all is what is the top level understanding about this machine. The user is not likely to go into the nitty gritty of how the snacks are coming into the machine, who is bringing the snacks, how they are organizing the machine, where is the way in which the money is getting collected, how is the change coming. These are not at all in the mind of any user of this facility called vending machine. Only one thing strikes: vending machine that allows users to buy snack items. In addition, a user can find out the caloric content of his or her choice. So, they can purchase snacks which have a total calorie of let us say 500 calories, 600 calories, whatever comes we will purchase. So, this is how the idea of vending machine happens in the mind of the user. Operating this machine is based on what he or she is thinking. They will simply press the button near the snack they want to buy, automatically the price and the calorie value comes, the number of snacks purchased, the total calories, the total price, put the money, get the change, and then out comes the snack items. We are not really likely to think of anything more than that. That is the simplest way in which we can make people work with the machines. They need not do a PhD in a university, they need not learn so many things. Now, what is the secret of this simplicity? The secret of the simplicity is that the user who is doing the task is having a set of things or objects in mind. If these objects are visible, they will simply go ahead and use them. Well, in the case of vending machine, these are all tangible machines, tangible snack items. Today, we are having users buying online. They see it online. Amazon was the beginning of that exercise. We were seeing the book on the Amazon. Those days, the debates were always there. Going to the bookshop, getting a feel for the book and purchasing is not the same as going to the online bookshop, clicking the cover page of the book, see what is inside. How much ever the online environment attempted to give us some feel for the book, the content, the purchase decisions were not really the same as they were when we went to the bookshop. Well, differences are there, things have changed. Now, what is impressive about this online is that they have completely converted it into the way the user would want to perceive the books, not the computer programmer talking about saying that what is the code of the book. Can you give me the ISBN number of the book? Very difficult. Very difficult to remember ISBN number of the book. Can you at least tell me something about the author? I do not know much about the author. Roughly I can tell this is the author, some names are there, some words I remember. We are not likely to go so prepared. Most of the students are like that. We tell that they should take down notes in the library, but then none of us are so good in keeping track of the notes with all the details. We are highly prone to requesting for a reprographic service or what is called Xerox photocopying rather than taking down notes. So, these are all the matters of serious contention also. Is it sticking to the mind is the question. The answer is, why should it? The machine should not dominate my mind. What is my goal? The snack. Am I getting the snack? Am I solving my puzzles? Am I getting the correct change? Then why should I bother about the machine? Everything has pluses and minuses. Everything has advantages, everything has disadvantages. So, what we are talking about is a certain type of activities, a certain type of automated activities to be precise, that are modeled on the way the user would like to work with them, rather than a computer programmer telling that this is how we solve the problem that you are facing. Now, you do not have the problem in mind. These are the 20 to 30 instructions, they are all put on this machine, just follow the instructions. only 20 to 30 instructions. The real world problem vanished, the real world vanished. Everything is dragging all the people into the machine the way the machine dictates, whereas here the user is in the command. Why? What is the need for keeping the user and the way he or she thinks above everything? Because that is when the users will think of more complexity easily. The more you have, the more you want. Today we are seeing only snacks. Once the users get on with these snacks, tomorrow they will ask for beverages. Why can't we have some cold soft drinks? If you can sell the snacks, you can also have soft drinks. Gradually the user will build further what we want to do more to make our businesses happen. The idea is good. We started with only books. Now you see how Amazon is ruling the roost. Everything is online. Just simply talk. Now Amazon web server is a course in itself. I myself attended a 5-day program on Amazon, 5-level courses. Amazon web server is a course in itself. How did it begin? Simply as an online bookstore. This was way back in 2000 when I opted to go for an electronic version of a book that was accepted for publication, my own book that was accepted for publication. There were two online bookstores, one was Barnes and Nobles, the other one was Amazon. So, my publisher was very nice in giving me those offers at a very affordable price, saying that we will also host it online, so that you will have better visibility. I still remember all the debates that were going on around that. Every new technology is like that. The idea that I have been talking about did not happen easily. For 4 decades, people were still saying that no, computer programming, automation should be done like before. Please pluck the problem out of the context, get it onto your table, your workspace, because you can't express it in the kind of science, you can't express it in the kinds of mathematical formulae that can be verified and validated. The abstraction which you create is in your office space. Do whatever you want, get that solution, push it onto the machine, sell the solution and the machine to the fellow who created the problem and who wanted the problem to be solved at a price. So, it keeps on doing the same exercise. So, what we have done is we have slightly challenged that model, said that is all nice, it is all good, we talked about functionality, how does it, we say how does the machine do this, but then the very description of the machine, the specification, a vending machine holds a number of snack items, all these nice ideas about the problem eventually become only 20 to 30 instructions. The problem is forgotten, we become more machinized rather than human to think of what more do I want. It is doing this, what else do I want? So, by pushing whatever can be pushed into the way the user thinks, you are likely to do more complex exercises easily, build further. We celebrate complexity, more complexity will come. Day after tomorrow, we will tell that let it also come in a pipeline to a place where I am sitting, let us say in airport, why not? You simply select it from your mobile, the vending machine is there, it is connected to Wi-Fi, connect from your mobile, select what you want, let the snack come to where you are sitting, you do not have to go to the vending machine at all. So, you see, once the user gets the hang of what this machine is doing according to what he or she wants to do, we will build more. The business increases, we can address complexity more easily, but then it is a different paradigm. It is not like what we have been doing for 4 decades, it is called object oriented. So, the specification is like this: a vending machine holds a number of snack items and displays the list of snack items and their prices through an user interface with a display screen and buttons for making selections. In addition, the vending machine has a receptacle for money and an item dispenser. A user can make a selection and query for the number of calories of a snack item. The calories are displayed on pressing a button. A user can place the money in the receptacle and select an item. A vending machine holds a number of snack items. See now what is highlighted. What is highlighted is precisely what the user is thinking. The step 1 is the user is only thinking of this. The same specification, the step 1, very quickly we have highlighted what the user is having in the mind: vending machine, snack items, list, prices. user interface, display screen, buttons, selections, receptacle, money, item disposer, calories, button, receptacle, that is all. So, now what are the other words doing? If the blue words in step 1 are what we are talking about is what is user having in mind, the other words in the specification are expected to connect them, tell roughly that this is how the user is linking those ideas. The blue words, the words colored in blue are so nice, they are the things that are dominating, that is the objects, and the red words are those that are linking the objects, hopefully in the same manner as the user wants to. Well, there is no reason to believe that a typical user would want to look at the vending machine and immediately look at where to collect the snack items, skipping everything else. It does not matter to me. As long as these objects in blue are noted, whichever sequence the user is going through, the machine should be comfortable in behaving as per the user's needs. So, the red words, the red colored words are hopefully connecting these objects. So, the $1,000,000 puzzle in object oriented analysis and design is therefore, what are the objects, how to connect them in a manner where whichever way the user is using on all these objects, the essential work is done. So, that is a different analysis, that is a different design, and whether we like it or not, we have had most of the nouns are objects and classes, some nouns are attributes. So, the idea is to collect in a given specification. It has been a very difficult exercise. Thinking of a problem is not easy. Converting that problem in a language where the specification is so obvious is even more difficult. But then we understand that it is humanly possible, it is done several times, that we should have all those nice things included in the specification. It is not likely to be sigmas, pi's, integrals, it is not likely to be a set of equations, it is just plain simple English. All blue colored words are the objects which they clearly think of, the user immediately thinks of it. You tell anything, we according to many, we think objects first. Please fetch a book from the library rack. What come into your mind? What are the things that come into the mind? The library, the stack, the place where these computer science books are there, some coding, some number, you will be able to fetch the book. So, most of the times we think that it is very natural for a human being to think about the action that is at hand in terms of the objects, the things with which he or she wants to interact. Very simple, fetch a book, it does like this, even a toddler would do that. Now, the next one which we talk is classification of the thing. This thing is different, the other thing is different, but we know that 5-6 things have to come together for me to complete the task. Therefore, we need to have an analysis, we need to have a design by which people are not unnecessarily connecting things. The design will dictate, saying that only these connections among the things will work, others we do not even care. There is no reason to believe that other connections will be attempted also, but still the design draws a line saying that these things can be used like this and not in any other way. So, what we have done in these nice set of thoughts is that the user is likely to think of the objects and things that are absolutely necessary according to him or her to solve the task at hand, to make the thing at hand work. And we do the analysis and design to make sure that the analysis is positioning these things correctly, these objects correctly, and the design is telling that you cannot do more than this. This is a limit. You cannot, for example, throw out a stack of books, you cannot throw out fling a library card here and there. So, we have a design to ensure that the interactions and relationships are all oriented towards the goal, because all users are not natively competent. Now, please understand that the design, the analysis makes it so simple that the user does not even require a user manual, it is effortless, it speaks for itself. There is no need to study a 10-page document on how to use a vending machine. Even for the first timer, you simply go there and then look at the vending machine. In a few minutes of simply jumbling here and there, you will figure it out what to do. We are reasonably good in understanding that way of working with the machines. So, we can easily figure it out saying that this is probably this is probably this. So, the user interface is so simple, and what we call it is effortless, it speaks for itself. However, please remember that there are so many occasions where we forget to take the change. In a hurry to catch the flight, we collect the snack, but we forget to collect the change. Which should come first? The change should come first, then the snack should come, because the goal is very clear. The user's goal is very clear, to purchase a snack. Once the snack comes, that fellow will go away with the snack, the change can come later. So many times it has happened, people have forgotten to collect the change, people have done we ordered one or two, suddenly it got stuck, they do not remember how many things have been taken. It is not that we have attempted to make everything error free, there are such errors possible. Within the cost, within the business constraints, we will offer as much as support for the error conditions as possible, but there are certain things where the user is responsible also to check how many items they have been ordered, is it there, is it not there. These are all the things which we wish to make them check, cross check, take the change, check the change and then go, otherwise there is no solution. It is not that the user is simply out of picture, it is not true. The user is also having a role. So, the design should simply tell that something should tell, please collect, like what we are doing in an ATM card for example. There were days when the ATM machines were different. I will simply put the card once in and take it out immediately. So, once the cash comes, I will leave. It does not occur to me that I have to do anything more than collect the cash, because I went to the ATM machine only to collect the cash, to get the cash. Once the cash comes, I will collect and go. And now what is happening? They want the card to be there in the ATM machine until the transaction is over. Well, different theories exist. I am not saying in any manner that the earlier design was not appropriate or the new design is better. The new design is like this. There are a substantial number of ATM machines that want the card to be there until the transaction is deemed complete. Then what happens? Somebody takes the cash and goes away, the ATM card is forgotten. Therefore, what is the meaning? They will have more technology, some lights will come and some voice will come, please collect your card now, the voice input. In addition to collecting the cash at the end of the transaction, you should. These are all quite exciting also. I still remember watching several users who are so new to technology almost losing their breath as the processing is happening. It is money. As the processing is happening, they watch breathtakingly, they will watch what happens next time. It is nice, but then that is how technology becomes acceptable very easily to the users. It speaks for itself, it tells them what to do, and we think that going object oriented, using the correct kind of analysis and design is likely to enhance this kind of an easy equation between lot of users and the machine and the automation, and they would want more, the business will thrive, the quality of service will thrive, the people we are servicing will get more things to do at less, do more with less. These are all the ideas which we have been building. In summary, we will talk about more and more complexity. So, if it is problem specific, first comes the vending machine, next comes the snack item, next comes the price, next comes calories, next comes selection, next comes the user. So, where is the user? At the fag end. So, this is what happens. In the way when we were looking at it as every problem, where is the user? The user is coming at the end. So, you want to have an automatic vending machine. Which brand of vending machine is appropriate? Should we have a vending machine for 10 items, 20 items, 5 items, 30 items? What are the kind of snack items? Should we have only chocolates? Should we have those nice fancy looking packed items? What are the snack items? So, what happens is we talk about 5 different functionalities first, because our problem is not what the user wants. Our problem is what is the vending machine? What are you talking about when you say it is a vending machine? I still remember so many things were happening with an automatic milk vending machine. When I was very young, we were talking about an automatic milk vending machine. So, we would not know what to do when the milkman does not come or we need more milk. We have to simply carry a can, go to that automatic vending machine, milk vending machine, and do that. How do you know 1 liter milk has come? Do we carry correctly 1 liter? At least when they are selling, it is 500 ml. It is all written on the sachet, some brand is there, so it will stop somewhere. Is it equal to 500 ml? Is it equal to 1000 ml? Only one item, but we had so many questions. So, in summary, what is happening is, while we become problem specific, correctly so, that is our problem, that is a problem for me, that is why I am in the business, and that is a problem which I am trying to solve. But then what is necessary is we will spend more and more and more and more time persuading people, saying that it is indeed happening like this. It will be more costlier, this attempt is more costlier. Snack item, the price can change tomorrow, there can be a festival discount, there can be so many other things that should be programmable, calories, selection. So, you see 5 different functionalities are nicely outlined immediately, and then we will tell how the user will talk. User interface will become much later. Now, what is it that we are trying to do? We are trying to make it presentation specific. The first thing that happens is the display screen, selection buttons, item dispenser, money receptacle, and that is just about what we have, only 4 things. The user, as I said, very quickly talks about display screen, selection buttons, item dispenser, money receptacle. Finish, matter is over. He knows how to interact after some time. So, the structural programming paradigm was functional, 5 functions. The object oriented paradigm is what are the operations which we are talking about, which object talks to what other object, matter is finished. All these things are now possible in a very nice set of terminology. Talk about C++, I do notice that most of the courses in MSc teach C++ now. Therefore, I have chosen the terminology that is happening in C++. The class is the cornerstone of C++. It gives C++ its identity from C. It is not simply saying that C++ is C++ something. It is a completely different way of thinking. Please remember that when we were C programmers, we were thinking like this on the left, structured programmer, or we were talking about like this, one after one. When we moved to C++, we talked completely differently. Class consists of both data and methods, defines properties and behavior of a set of entities, object and instance of a class, a variable. Now, these are the simple terminology like every new field has. This also has brought in along with it some nice terminology. Now, once again the question comes, for teaching purpose in C++, we have still been talking about rectangles, triangles, draw some graphics package, but how does it relate to real life? That is a question that we have to ask. Each time when we were talking about programming, we talk about teaching linked list. Where is the linked list happening in the minds of the users in the real life? The answer is very difficult. We do not see a linked list at all. But then we know that behind every problem solving exercise using computers, the first step of representing the data on which this machine is going to work as input and then convert it to output is something which we can never escape. The very computing model is like that. We need to have a well defined set of input data, the well defined set of output data, and we write a program, let us say 5 functions that convert the input data into output data. Now, in this process, we have completely taken over the problem in the way the user is experiencing, cast it on our desk in the way we understand that many of us can see this abstraction and very quickly go into the functions, write a mapper, write a function that transforms the input data into an output data and then push it into the machine works, the computing machine works. So, all the terms, terminologies with these examples, they look like this. This is how the program looks. But please remember that no user needs to look into all these things. What is the flip side of it? The flip side of it is something like telling that all that I need to know about the vending machine is display screen, a few buttons, one money tray, one snack tray. Is it enough? Most of the times, yes. If something goes wrong, then what will you do? It can happen any number of times. Again, coming back to the ATM example, the early days of ATM, they were very conscious about sensing the ATM, or the ATM card was very sensitive. So was the machine, the early machines, they were not so rugged. So what used to happen is, the moment you insert the ATM card, for any reason the machine is not comfortable reading even a small signal that is coming out of the card, it will simply accept the card and keep quiet. It happened once. A good friend of mine went on a Sunday 11 o'clock to a bank which had ATM. Only one place in Chennai at that time had an ATM machine, very sensitive machine. Even if a small speck of dust is there, it will take away the card. It does not reject the card, it will take away the card. Designs change based on the user perception. See how quickly we know what is the problem. You do not have to pour through this many lines of code, this many languages, very quickly we know where the problem is. It is very sensitive. The ATM card was inserted, something happened, that simply gulped the card is vanished. How will the user get the card? More importantly, is the cash also gone? How do you know? The money gone? When will the bank open? Only next day. So, the point is, we have to understand that the moment we become object oriented, certain things become very apparent, and that those certain things which become very apparent are very useful for us to build the next level of complexity, the next set of functionalities which we are contemplating. So, we talk about the class name, define a class type, class definition, data. So, this is how it is. Abstract the common attributes of a group of entities, their values determine the state of an. We will come back again to this. I am just giving you a quick example of what is it that we are talking about when we say it is a class of rectangles, out of which a rectangle of your choice is what we are defining using an abstraction, using an idea called class. How do you identify the classes, objects? That is the puzzle. Next comes the most important aspect, like we are talking about input data and storing in the memory. We can't do anything outside of it, it is still a stored program concept. We have to store all the input data, we have to get all the output data in the memory. So, we started talking about objects, how they are stored in the memory, in the computer memory, how many variables are there. Every object is having two variables here. There is a member function, two functions, two variables. A class is having three instances, object 1, object 2, object 3. Every object has common functions f1 and a function 1 and function 2. Every object has two variables, variable 1 and variable 2. What happens on object 2 is not the same as what is happening on object 1, but then what is to be done on the variables is same on all the objects. That is why they are forming a class. Now, is it stored like this in the memory? The answer is not necessarily. We have to find out how the memory is organized, but please understand that it is lot more simpler to talk about the way in which we perceive. These are the snacks, this is what I want to purchase, this is the calorie value I have in mind, this is the money I have in mind. So, on every snack, snack is a class, snack 1, snack 2, snack 3. Every snack, snack 1 will have calorie, price, snack 2 will have calorie, price, snack 3 will have calorie, price. On all these snacks, snack 1, snack 2, snack 3, the class functions the same. Is this snack selected? Automatically you will get the details, dispensed, two functions, selected, dispensed. Next set of slides will show all those. Thank you. We end the session today. We will meet again in the next session.